back to Calbeckistan, a place where anybody can learn math. I'm Mr. Calbeck. Great to see you guys all here today. Today our lesson is we're going to be looking how to multiply fractions like this. These are called rational expressions, and we're going to learn how to multiply them today. They look horrible. I'm not going to lie. People look at this and they'll seize up. They think that the fractions are going to chase them with an axe. It's really, it brings up this fear deep down inside of us. But I think we can actually break this down into some small pieces that's going to make this an easy thing for us to do. All right, so hopefully you can stick with me here, and hopefully after this video you're going to be able to understand this a little bit better. But before we jump into a problem this challenging, I want us to take a step back. Let's remember a little bit about multiplying fractions and see if we can break down some of the small pieces and we can apply them to this more difficult problem. So here's a simpler case of multiplying fractions that I think will give us some insight on how we do this particular kind of problem. When you're multiplying fractions, if you remember from 4th and 5th grade, some of you don't, it's okay. Remember what we do is we multiply the numerators together and we multiply the denominators together. Or as my class likes to say, we go straight across. So I do 1 times 3 and 2 times 4. So you're actually given a new problem here with one big fraction. We have 1 times 3 and 2 times 4. So essentially you can rewrite every fraction like this. In this particular case, we would simplify this down. 1 times 3 is just 3. 2 times 4 is just 8. And so your final answer would be that. And of course, you're going to box your answers for your math teachers because you love your math teachers and you don't want them to have to search for the answer that you wrote down. Thank you for doing that, by the way. So here we go. This is our particular answer. And so if we can remember that, I think we can apply this to our problem later. All right, here's one other problem we could be looking at that's going to give us one more piece of information we need before we can solve the more challenging one. What we see here, again, same kind of thing. When we multiply fractions, we go straight across. So what we're going to do here is we're going to multiply 3 times 5 and 4 times 6. That's going to give us, again, one big fraction, 3 times 5 over 4 times 6. And here's what we need to realize. When I have this problem right here, this is going to give us 15 over 24. I can reduce this problem. Now, reducing in math is kind of a strange idea. A lot of us forget to do that. What your math teachers have probably told you in the past is to look for a number that divides evenly on the top and the bottom. Some of you probably already did that in your head. You said, well, 15 is divisible by 3, and 24 is divisible by 3. 15 divided by 3 is 5. 24 divided by 3 is 8. And that's our final answer. This is not as easy to see when you're dealing with big X's and Y's and strange expressions. So I'm going to show you a little bit more of why we are allowed to do this. When we have a fraction, 15 over 24, we can actually factor that. Again, that's the first step on any rational expression. You'll hear me talk about that later in the video. But we need to factor this. And factoring simply means to find the two numbers that multiply together to give us these. So let's go ahead and look at what that would be. The factors of 15, we could say they're 5 and 3. The factors of 24, there's a bunch of them, but the one that we're interested in is 8 and 3. So instead of writing 15, I wrote 5 times 3. Instead of 24, I wrote 8 times 3. And what you notice here is that I have 3 divided by 3. 3 divided by 3 is 1. I can multiply or divide by 1 without changing anything. What I really got here is a big 1. If you've watched any of my other rational expressions videos, you'll have seen this big 1 show up a lot of times. But what this allows me to do, I can take this. This is really just a 1. It doesn't change the problem at all. I can take 5 over 8 and multiply it by 1 all day, and it still ends up as 5 over 8. So what we really see here is this cancels out. So if you ever see your teachers talk about canceling something out, it's not that those numbers disappear, it's that they divide into a big 1. So my actual answer is 5/8. And essentially what we're going to be looking for in our bigger problems with rational expressions is we're going to be looking for big 1s. We're going to factor these problems. We're going to see if there's anything that's the same on the top and the bottom, because when we do that, it's going to give us a big 1 that we can divide out. All right, so let's jump back to that harder question now. All right, so now that we've looked at that easier case, let's see if we can jump back in to this more difficult case and apply those principles that we learned from the easier fractions to this. So what we want to do in a problem like this, remember my rule with dealing with rational expressions, is we always want to factor everything we can first. It's going to allow us to simplify things, and it's going to allow us to see some of these pieces that we wouldn't have seen otherwise. And there's two different kinds of factoring in this problem. And again, most of these sorts of problems, if you're doing them on a worksheet or on a test, are going to have a lot of factoring. So be looking for it. Always start with factoring. The first and easiest kind of factoring you actually learn in 8th grade. Some of you might have waited until Algebra 1 to really learn this. But it's called factoring out a common multiple. And we can see that in this one right here. The way that factoring out a common multiple works is that you're looking for a number that divides evenly into both terms. So notice here there's a 2x in this one and an 18. Both of these numbers are divisible by 2. So what we can do is we can rewrite this after dividing it by 2. So if I divide everything here by 2, I end up with x minus 9. 2x divided by 2 is x. 18 divided by 2 is 9. It's still negative, by the way. But since I can't do it to both sides, it shoots out right there and becomes a 2. You can even think about this as undistributing your term. Okay, so instead of thinking about it as factoring, think about it as pulling a 2 out. And you can always check to see if you get it right by distributing it back in. So 2 times x should give you 2x. 2 times negative 9 should give you negative 18. So we can see that that works. So let's go ahead and rewrite this one. It's now 2x minus 9, or 2 times x minus 9. The other one that we can factor is this one right here. Now, I don't have time in the video to re-go over how to factor a quadratic. So you're welcome to take a look at other videos that I'm planning to post on factoring, for those of you who forgot. But the simple answer is this. When you're factoring a quadratic, and the big trick here is that there is no term in front of the x squared. It's just a ninja 1 right there. But the basic thing is what you're looking for is looking for two numbers that multiply to be 15 and add to be 8. That's the short answer. This only works, again, if you have a 1x squared term. If you have anything else, it takes a little bit more work. But if it's simple like this, you can just ask yourself that question. So two numbers that multiply to be 15, add to be 8. Sometimes I set up a little chart to help me. I know that multiplies to be 15, adds to be 8. And hopefully you can come up with two numbers that work for that. The numbers here are 5 and 3. Other possibilities you could come up with are 1 and 15, but those don't work because they don't add up to be 8. So this can be rewritten once you find these numbers as simply x plus 5 and x plus 3. And again, if this is confusing to you, feel free to look at some of my other videos. I will be posting some on how to factor later in the year. So let's go ahead and rewrite this one as x plus 5 and x plus 3. And we're going to see what we've got left now. Okay. The other thing to remember, if you have two terms and they're not factored or anything else, go ahead and put parentheses around them. By doing that, it's going to allow you to see the factors more easily. All right. So now we can multiply. We factored everything. We can multiply. Remember, when we multiply fractions, all that you're going to do, you're going to multiply the numerators together, the denominators together, or you can think about it as just straight across. Now, what I would recommend for you to do, instead of distributing everything and getting these big, horrible polynomials together, leave everything in its factored form and kind of just crunch them together. So, in our example earlier, we looked at 1/2 times 3/4. And instead of multiplying that and having 3/8, you could multiply this and write 3 times 1 over 2 times 4 and leave it like this. Leave everything multiplied in one big fraction. I'll show you why we're going to do that in a minute. So let's go ahead and do that together. I'm going to rewrite this. So let's see if I can do it real quick. I did it. The magic of really cheap video editing. I don't know if you can tell from the audio quality in this that I'm not exactly a big budget operation here. So what I did, again, I just crunched these together. I did move the 2 out in front. Generally, if you have a constant term, putting it in front is going to make it look more natural to you guys. So I'd recommend that. If you have more than one constant term, just put them together and connect them with multiplication signs. Again, everything can be factored. Now what we're going to be looking for here is we want to simplify at the very end. That's kind of the goal. So in this particular case, I'm going to be looking for things that are the same on the top and the bottom. Things that are the same on the top and the bottom will cancel out. They cancel out because they divide into 1. Right? Anything divided by itself, no matter what it is, like you could have 2 divided by 2, that equals 1. Right? X divided by x equals 1. Anything divided by itself equals 1, and when I multiply 1 times the rest of this, it stays the same. So that's the reason why things cancel out. They don't just disappear, they don't turn into a 0, they actually divide into a 1. So if your teacher's telling you to cancel things out, that's why it works. What I like to do to remind myself of this, because it can be really important, is to draw a really big 1. My students like to make fun of my 1s here. And I don't blame them, because they're ridiculous. But x plus 3 over x plus 3 divides into a big 1. So it cancels out. So you can have a little bit of fun with that. You can also draw another 1 here. There's an x minus 9 over x minus 9. It doesn't matter that they're on opposite sides here. The important thing is that there's 1 on the top and 1 on the bottom. We can draw another big 1 here. This is going to look way worse. And then you'll start to see why people make fun of me for this. Let's try this. Yeah. Oh, nailed it. Wow. I'm really wondering what's going on with those Ninja 1s right there. I was hoping this was going to be a PG video, and I'm starting to wonder if this might be rated R. I'll let you think about that. Okay, so let's look at what's left here. The x minus 9 cancels out. The x plus 3 cancels out. So let's see what we have left. We'll use another magic of great video editing. Nailed it. All right, and we see here we have 2 times x plus 5 over 1. So that's what we've got here. One other quick thing on this. Notice I put the 1 there again. That's one of those big reasons why we draw the big ones. Because when it's gone, it doesn't completely disappear. Whatever's left is actually a 1. So make sure you have that. In this particular case, dividing by 1 doesn't really change it. So if you want to write it like this, that's totally fine. It's more important when the 1 is left on the top. You have to make sure that you put that 1 in there. So I'd love it if you get in the habit of putting a 1 wherever something cancels out completely. All right. We didn't talk about excluded values in this video, but there are numbers that x cannot be in this problem. We'll talk about that in another video. All right, if you're watching at home, I'd like you to try this one. If you think you can do it on your own, feel free to fast forward to the end where I'm going to give you the answer. If you didn't get that answer right, feel free to rewind, and then I'll show you how to do this problem as well. All right, so go ahead and hit pause and see if you can do that right now. All right, if you're still watching, that means that you probably wanted some help on this. But let's go ahead and take a look at this. Remember, 2 kinds of factoring. We're going to be looking for common multiples, factoring quadratics. So in this case, there's 2 common multiples we can factor out, and 1 quadratic. So we'll start with the easy ones. This one, there's a common multiple here of 4. So this is going to factor to be 4 times x minus 8, because both of these are divisible by 8. Again, if you're worried about what you can, if you factor correctly, remember you can distribute it back in. This one over here, we can factor out a 10. Both of these are divisible by 10. So you should end up with 10 times x minus 4. Looks pretty good. And then up here, let's see what we got left. This one is going to factor. Again, we're looking for two numbers that multiply to be negative 16 and add to be negative 6. In this case, since it multiplies to be a negative, we know that one has to be negative, one has to be positive. So that's going to give me two options. I can have 1 and 16, or 2 and 8, or 4 and 4, I guess we work too. But there's only one of those that could possibly add up to be negative 6, and that's if 2 and 8, and if the 8 is negative. Be really careful on which one you make negative, because it does matter. That's going to give you x minus 8 and x plus 2. So now let's go ahead and crunch these together. We have all of these factored. Let's push them together. Let's see what we can get here. All right, once we push them together, it should look like this. Again, notice I put the numbers. They're called constants because they don't have a variable. They're out in front. Now we're going to be looking for is a big 1. So let's see if we can find any. There's actually only one big 1 in this problem. That's really easy to find. That's x minus 8. So those two are going to cancel out. So you can go ahead and eliminate those ones because, again, they divide into 1. So I'm going to erase those real quickly. What we have left then is we have a 4 on the top and a 10 on the bottom. We're almost done here. None of these are going to cancel out, but we do see this 4 and this 10. That's a regular fraction. If you forget everything else, this one will reduce. And again, the reason it reduces, because you can write this as 2 times 2 over 5 times 2. There is actually a big 1 in this problem. If you remember from elementary school, factoring actually just means finding the numbers that multiply to get your answer. In this case, 2 and 2 and 5 and 2, they're factors of 4 and 10 respectively. So we can look at this and see, oh, there's a big 1 right there. So this will actually reduce and give you 2 over 5. And that's the final answer here on this. Again, we did not talk about excluded values in this problem. But again, if you're having those kinds of issues, some of your teachers might talk about finding the domain of your problem. That's the same idea. Or finding discontinuities. That's the same idea. So if you hear any of those words, we will talk about those in a later video. So please look for that. Anyway, hope you guys have a wonderful day. Give me a like, and I hope that this has been a helpful lesson for you. Let me know in the comments if there's anything else you'd like to see that I haven't covered.